Okay, let's dive right into this explainer and explore the really fascinating journey of the modern data ecosystem. I mean, we're going to look at everything from its humblest beginnings all the way to the cutting edge of artificial intelligence. We hear a lot of buzzwords thrown around today, right? AI, machine learning, big data. But none of those incredible technologies just, exist in a vacuum. They're actually the result of decades of intense problem solving.
Think about it for a second. Data is absolutely everywhere today, but turning it into something actually useful, well, that's a massive logistical challenge, and it definitely didn't just solve itself overnight. Moving from dusty filing cabinets to algorithms that can predict medical diagnoses or, drive cars, that required a total reinvention of how we capture, store, and process information. It's literally the story of building the most complex plumbing system in human history.
So here's how we're going to break it down. We're tracing this evolution across 5 key eras: the dawn of digital data, move into strategic analytics, the big data explosion, the data engineering backbone, and finally, powering the AI future. Let's get into it.
Starting with part 1, the dawn of digital data.
This is where the foundation was laid.
In the very beginning, information systems were built purely to just keep the lights on, run day-to-day operations. Organizations slowly evolved from physical, paper-stuffed in filing cabinets, which was incredibly slow and super prone to error, to digital departmental applications. But there was a massive catch. HR's payroll system and finance's accounting system totally siloed. So the information was finally digitized, sure, but it was completely trapped in these isolated pockets all over the company.
To make those early digital systems work, we relied heavily on operational databases, or OLTP. That's online transaction processing. Now, these systems are designed to efficiently process a massive number of daily transactions in real time. They really are the unsung heroes powering your everyday life. When you withdraw cash from an ATM, when you register at a hospital or book a flight, you're interacting with an OLTP database. They guarantee blazing speed and strict data integrity. But they have one major limitation. They're built entirely for the present moment, not for looking back and spotting long-term trends.
Which brings us to part 2, moving to strategic analytics and the hunt for deeper insights.
As businesses started growing rapidly, managers suddenly realized they were kind of flying blind. They couldn't spot long-term strategic trends using systems that were only built for rapid-fire, real-time transactions. So to make better decisions, the whole industry had to shift its mindset. We had to move from operational systems built to run the business to a completely new architecture built to analyze the business. Enter the data warehouse. Unlike an operational database that only cares about what's happening today, a data warehouse is historical, it's integrated, and it's specifically designed to handle really complex queries across years and years of data.
But to make a data warehouse actually work, you have to rely on the ETL process. That's extract, transform, and load. Because think about it, you can't just dump raw, messy data from your daily operations straight into a warehouse. No way. First, you've got to extract it from all those different, siloed sources. Then comes the really hard part, transforming it. You have to scrub it clean, standardize it, and make sure that a client in one system perfectly matches a customer in another. And finally, you load that pristine, reliable data into the warehouse, where business users can actually analyze it to make informed decisions.
Now, once you have that data warehouse set up, an organization's analytics maturity generally evolves in 4 distinct steps. First, they start with descriptive analytics, which is basically just looking at dashboards to see what happened, like reviewing last quarter sales. Then they move up to diagnostic analytics to figure out why it happened. But the real magic, that hits with predictive analytics, where you start using statistical models to actually forecast what will happen next. And finally, you reach prescriptive analytics. This is where the system literally tells the business what they should do, like exactly how much inventory to order right before a massive winter storm hits.
All right, moving to part 3, the big data explosion. This is where scale and complexity go off the charts.
Right as we finally figured out that analytics maturity model, the scale just completely broke. Suddenly, data was everywhere. We moved way, way beyond just sales receipts and HR records and started dealing with 4 massive new data sources. First, the Internet of People. Think social media interactions and billions of emails. Second, the Internet of Things, streaming constantly from smart sensors and factory machines 24/7. Third, the Internet of Places, mapping our physical world through GPS and autonomous vehicles. And finally, the Internet of Content, just this endless, chaotic ocean of videos, images, and unstructured news.
Now, all of this created a massive challenge that the industry famously defined as the 5 V's of big data. The very nature of information had fundamentally changed. We suddenly had to manage unprecedented volume. We're talking billions of transactions. High velocity, meaning data streaming in at real-time speeds. A huge variety of formats, from structured tables to totally unstructured video files. Uncertain veracity, where you're constantly dealing with messy data or questioning its trustworthiness. In all of this with the ultimate goal of somehow extracting actual value from the chaos.
To handle those 5 Vs without going totally bankrupt buying expensive traditional hardware servers, businesses had to adapt, and fast. The absolute savior here was cloud computing. By migrating to platforms like AWS, Microsoft Azure, or Google Cloud, organizations suddenly gained elastic storage and instant scalability. You no longer had to buy and maintain these giant, heavily air-conditioned server racks. Instead, you just rented the exact computing power you needed right when you needed it using a simple pay-as-you-go model. Honestly, it was the only physical way to survive the big data explosion. Next up is Part 4, the data engineering backbone, or what we like to call the hidden plumbing. Because look, even with the virtually limitless power of the cloud, raw data is absolutely useless without the complex plumbing required to actually bring it to the tap. This end-to-end data engineering pipeline, it is a total marvel of modern software. It takes raw data from all those wild sources we just talked about, ingests it either in huge batches or through real-time streams, cleans it up, and stores it highly efficiently. Then, finally, it serves it up perfectly so analysts can build their dashboards and data scientists can actually train their models. Simply put, without this vital discipline building reliable and scalable systems, everything else literally grinds to a halt. All those fancy applications your business relies on, they simply cannot function. Without data engineering, there are no analytics. There are no insightful dashboards. And, most importantly for today's world, there is absolutely no AI. Which brings us to our final section, Part 5, Powering the AI Future, the ultimate destination. This is where we finally see how all of this carefully engineered data serves as the actual fuel for artificial intelligence and machine learning. You know, applications like your personalized Netflix recommendations, real-time bank fraud detection, or advanced medical diagnosis tools. They don't just magically work. They are completely 100% dependent on a continuous flow of high-quality data. AI needs massive, clean data sets to learn patterns and make accurate, real-time predictions. The old saying holds true. Garbage in means garbage out. And data engineering provides exactly the pristine, high-grade fuel that these complex models require. As the industry saying goes, AI and ML deliver value only when data is accessible, reliable, and actionable. It's really not just about having the smartest algorithms or the most incredibly complex mathematics. It is entirely about having the right data at the precise right time in the exact right format. That right there? That is the true secret behind the entire AI revolution. And that brings us to the end of our explainer. Data really isn't just some byproduct of doing business anymore. When it's engineered correctly, it is the business. Looking back from physical paper to the cloud, all the way to advanced AI, the evolution is just stunning. But it leaves us with a pretty provocative thought to walk away with. If data is truly the engine of the future, is your organization's plumbing actually built to handle the flow? Think about where your systems stand today. Because let's face it, the evolution is only moving faster.